Alright, if you're doing these in order, this is going to be the last worksheet on the math section, specifically on weighted averages. 6 questions. Let's go through them. There are 20 students in Mr. Jones's class. 5 of them are 16, while the remaining are 17. Well, if 5 out of 20 students are 16 and the remainder are 17, 5 out of 20, if I just kind of go over here and say 5 out of 20, 5 out of 20 is equal to, I hate it when this does this, is equal to 1/4, or 0.25, or 25%. Alright, which means the remainder is 75%. So 25% of them are 16. So 1/4 or 25% are 16. While the remaining students, which is 3/4 of the students, are going to be 17. So the question is, what is the average age of a student? Well, let's stop for just a second. Before you sit down and do a bunch of math, it's really helpful to go and estimate. So what do we know about the average age of the student? What can it be, and what can't it be? So pause the video for a second. See if you can logically reason about what you think the average is going to be. All right, welcome back. Certainly if the youngest students are 16 and the oldest students are 17, that means the average age has to be somewhere between them, between 16 and 17. And there are only 5 students who are 16, and there are going to be 15 students remaining, right, who are going to be 17. So that means the age should be between 16 and 17 and closer to 17. So let's say, once we do the math, let's make sure that we actually come up with that. Well, what's 1/4 of 16? Well, we end up crossing that out because 16 divided by 4 is 4. So that's going to give me a total of 4. That's how much that gives me. Well, let's come over here and look at the 3 times 17 divided by 4. Well, that's not as easy. So 3 times 17 is 51. And we divide that by 4. Well, how many times will 4 go into 51? Well, if we think about it, 4 will go in 12 times with 3 left over. You should be able to do that long division. 12 times 4 is 48. And then that leaves 3 left over, 3/4. So if I add these two things together, I get a total of 16 and 3/4. That's my total age. Does that make sense? Well, it's somewhere between 16 and 17, and there are more who are 17 than 16, so that looks like a good answer to me. Alright, we have 20% of a group of athletes weigh 100 pounds, and the remaining athletes weigh 150. So what's the average weight? Again, I'd estimate first, alright, to make sure that your answers are somewhat reasonable. Clearly, I need to be between 100 and 150. Am I going to be closer to 100 or closer to 150? Sure, I'm going to be closer to 150 because there are only 20% who weigh 100, and the majority, 80%, are going to weigh 150. So how do I do that? Well, 20% or 0.2 times 100, and 0.8 or 80% times 150. Well, again, I do a lot of mental math. So 0.2 times 100 is going to be 20, because 2 times 100 would be 200, but if I move the decimal point, it's 20. Well, I can't do 0.8 times 15 in my head. I could do 8 times 15, or I could say, well, 15, this 1%, or 0.1 times 150 would be 15, 0.2 would be 30, 0.4 then would be 60, which means 0.8, did I do that right? Let's try that again. 0.1 is 15, 0.2 is 30, 0.4 is 60, 0.8 would then be twice 60, or 120. Now I add those two numbers together and I get 140. Does it make sense that the average weight would be about 140? Sure it would. So that's my answer, is 140. Alright, how about this one? Mr. Broughman has a wrestling team now. There are 5 boys, and 10 boys. So you're going to have to do this 3 times now. Right? Pause the video if you haven't done it and do it yourself. Right? It doesn't help just to watch me. Right? It's real easy when I do it. It's not as easy when you do it. Okay? So, assuming you've done it now, he has 5 boys who are in the 120-pound class, 5 boys who are in the 130, and 10 boys who are in the 140. That gives me a total of 20 boys. So 1/4 of them are 120 pounds. 1/4 of them, stop it, 1/4 of them are 130 pounds. and 2/4 of them, or 1/2 of them, are 140 pounds. So again, estimate first. What do you expect to happen? Well, clearly I need to be around 130, but there are more kids who are 140 than there are who are 120, so I'm going to be skewed. I'm going to be up in here somewhere. Right? So let's see what happens when I do this. Well, half of 120 is 60, so 1/4 would be 30. And down here I can do half of 140, which is 70. Those are easy. It's this one that's a little hard. So I have to do 0.25 times 130. Well, let's see. Half of 130 would be 65. Right? So what's half of 65? Well, let's see. That would be 32.5, right? Excuse me. So if I take these numbers and add them up together, 30 plus 70 is 100. So this is going to be 132.5 is my average weight of a wrestler. Does that make sense? And it sure does. It's right between 130 and 140, which is what we expected. All right. Let's try number 4. Will goes to the farmer's market. He purchases some fruit that weighs half a pound and some that weighs a pound. Clearly our answer is going to be between them. Right? Well, what's right in between them? Well, right in between them is 0.75. But if only 40% is half a pound, that means 60% is 1 pound. I should be between 0.75 and 1, probably pretty close to 0.75. Well, let's see what happens. I have 40% of the fruit, 0.4, and I'm going to multiply that by 1/2, because that's half a pound each, and that gives me 0.2. The remaining fruit is 1 pound apiece, and that is 60% of the stuff, and 0.6 times 1 is 0.6. If I add those two numbers together, I get 0.8, and gee, is that close to 0.75, but a little bit bigger? Sure is. Sounds like a winner to me. My answer there is 0.8. How about number 5? All right, we have an average lineman weighing 200 backs. We have 3 different pieces of this. So we have 200-pound people, we have 180-pound people, and we have 140-pound people. And what do we have? Well, we have 20 linemen, 20 backs, and 10 receivers. So we've got a total of 50 people. So if I have 20 linemen out of 50, 20 out of 50, which is equal to 2/5, or is equal to 0.4. So I have 200 times 0.4. And over here I have 180 times, let's see, we have 20 backs. So again, I have 20 over 50, which is equal to 180 times 0.4. And we have 140, and we only have 10 receivers. So that's 10 out of 50. 10 out of 50 is equal to 0.2. You know, guys, something that can help you along here. Notice the 0.4, the 0.4, and the 0.2 all add up to a total of 1 because they're percentages, so they all have to be out of 100. That can kind of help you. Let's see, 200 times 0.4. Well, the easiest way for me to do that, mental math, is to say, well, 200 times 0.1 is 20, and I've got 4 of them. So 20 times 4 is 80. 180 times 4, well, 18. 18 times 2 is 36. 36 times 2 is 72. And 140, 14, and 14 is 28. If I add all those together, I notice I've got, let's see, the 2 and the 8 give me 10, and the 8 and the 2 give me 100, so I'm at 110, I'm at 180. So my answer here is 180 pounds. Well, that's between 140 and 200, and it's going to be closer to 180. So that makes sense. We're good. Take it to a hospital. 30% are born babies are 7 pounds. 60% are 8 pounds. Hello, where am I? There we are. Thank you. Right? And 10% are 9 pounds. So where am I going to be? Well, clearly I'm going to be close to 8 pounds. 60% of the babies are 8 pounds. So I'm going to be real close to 8 pounds. Right? Am I close? Am I above or below? Well, there are more babies born below than there are above. So I'm going to be a little bit below 8 pounds. Let's go and see what I come up with. I have 30%, which is 0.3, are 7 pounds. I have 60%, which is 0.6, are 8 pounds. And I have 10% times 9 pounds. Notice again, if I add up the 0.3, the 0.6, and the 0.1, I come up with 100%. All right, or 1. Let's go and do this. 0.3 times 7, that's going to be 2.1. 0.6 times 8, that's 4.8. And 0.1 times 9 is going to be 0.9. If I add all these together, I add up the 2.1 and the 0.9, that comes up to 3. So I add that, and I get 7.8 pounds as the average weight of a baby at this hospital. Right? Does that make sense? I think it does. Right? So, anyway, that's it for this worksheet. We're done with the math section. Any questions? Come find me in class. I'm happy to help you. See you in class.